Okay, let's see the another questions. See now here, so the number of protons, neutrons and electrons present in lutetium Lu 71, 175 respectively are what? So we have to find out number of protons, neutrons and electrons, where here in lutetium 71, 175. So for any element if they give like this, how can you say that? See, remember, so always protons are present here at the downside. Okay, so protons are always present here downside. So this 71 is nothing but number of protons. Okay, so protons equals to here, protons equals to how many? 71. And next one, after that, neutrons. So neutrons here, you cannot find the neutrons. You have to find the neutrons by a formula. So what is that? Neutrons is equals to here 175 is the atomic mass, 71 is what? Atomic number. So atomic mass minus atomic number, then you will get number of neutrons. So 175 minus 71. So what will be 5 minus 1? 4 and 7 0. So 104 neutrons are there. Okay, so neutrons are atomic mass minus atomic number. Okay, and next electrons. Here electrons is also here same. Here if it is here having no charge, then electrons are equals to this number downside. Okay, so electrons are also, how many electrons are there? So electrons number is also 71. Okay, if there is any plus charge or minus charge, you have to add here. If it is plus charge, 71 minus 1, 70. Here if it is minus charge, 71 plus 1, here 72. So like this. So protons 71, neutrons 104 and electrons are 71. So what will be your answer? It is I think yeah, option A is the answer. So next question. See, beryllium 2 plus is isoelectronic with which of the following? Okay, so beryllium 2 plus is isoelectronic. Isoelectronic means what? Same number of electrons. Isoelectronic is what? Same number of electrons. So beryllium 2 plus contains the electrons. So with that same number of electrons, which element is having in the options given? H plus, lithium plus, Na plus and Mg2 plus. First we have to check how many electrons are there in beryllium 2 plus. So you know that beryllium atomic number is how much? 4, is it right? Beryllium atomic number is 4. So but beryllium here is having plus 2. So plus 2 charge means what? It is losing 2 electrons. So it is losing 2 electrons. So that's why here atomic number is 4 means it is already having 4 electrons, and plus 2 means it is losing 2 electrons. So now it is having how many electrons? Only 2 electrons is there. So beryllium plus 2 is having 2 electrons. So now, so we have to check in the options whether they are having 2 electrons or not. Here see, first H plus. Hydrogen is actually, you know that atomic number 1. So plus means this electron also will be removed. So nothing is there. So it is not correct, option A. Option B is what? Lithium plus is given. Okay, first lithium atomic number is how much? 3. And in the options given plus 1. Plus 1 means what? So 1 electron is lost. So that's why it contains, now lithium plus 1 contains how many electrons? 2 electrons it contains. So our beryllium is also contains how many electrons? 2 electrons. So now beryllium 2 plus is isoelectronic with lithium plus 1. So option B is correct. So remaining, you see sodium. Sodium is actual atomic number 11. Plus means 11 minus 1. It contains 10 electrons. Magnesium atomic number 12. So 12 electrons. But plus 2 is there. So 12 minus 2, 10 electrons. So beryllium 2 plus and lithium plus are having same number of electrons. That's why isoelectronic. So next question. So which of the following series of transition in the spectrum of hydrogen atom falls in visible region? Understand? So here 4 series of hydrogen spectrum is given. So which one belongs to visible region? So visible region means you know that it contains we can see that with our naked eye. Okay, that is the visible region. So colors you can see. So in which region? So a bracket series is there, Lyman series is there, Balmer series is there, and Pasteur series is there. So bracket series belongs to, so it is IR region. Lyman series, you know that UV region. Balmer series belongs to, this is the visible region. Okay, Pasteur series, so this is also belongs to IR region. So Balmer series is the correct. Okay, so in the Balmer series of region, we see the visible light. Okay, so in the next question, see here we have a problem, small easy problem. So write what is that? Calculate the energy in joule corresponding to light of wavelength 45 nanometer. Okay, here what is asked? Here to calculate the energy. So in joules corresponding to light of wavelength 45 nanometers. And here in bracket given H. H value is nothing but what? Planck's constant. H value is nothing but Planck's constant. And C is nothing but what? Speed of light. Okay. Now, first we need to find out energy. We have to calculate energy means we need to know the formula for the energy. So what is the formula for the energy? So we know that energy formula E is equals to H into C by lambda. So you have to remember that this formula E is equal to Hc by lambda. E is energy. H value is Planck's constant. H value is what? Planck's constant. C value is velocity of light. C is velocity of light. And lambda is wavelength. Lambda is wavelength. So in the problem only given H value. What is the H value? 6.63 into 10 power minus 34. This is what? 6.63. So right, you substitute the values. So E is equals to 6.63 into 10 power minus 34 into C is what? Velocity of light. So in the problem only given 3 into 10 power 8 meters. So in meters they are given 3 into 10 power 8 meters per second or second inverse. Okay. So next by and wavelength. Wavelength is what? 45 nanometers. It is given in nanometers, but we have to write in meters because it is find out in asked to find out in joules. Joules is what? SI unit. Joules is what? SI unit. So nanometer is not SI unit. We need to convert into meters. So 1 nanometer equals to 10 power minus 9 meters. Okay. So there are nanometers, angstrom units are there. We can convert into meters and centimeters. So 1 nanometer equals to 10 power minus 9 meters. Okay. So you try to calculate and you have to choose which is the answer. Okay. So after the calculation, so you should get the value D 4.42 into 10 power minus 18. So next question. So according to Bohr theory, which of the following transitions in the hydrogen atom will give rise to the least energetic photon? Okay. So what is the question? According to Bohr's theory, which of the following transition in the hydrogen atom will give rise to the least energetic photon? Okay. So you know that in the hydrogen spectrum you will see transitions takes place. So from higher region to lower region. So here options are given. So option A, n is equal to 6 to n is equal to 1, n is equal to 5 to n is equal to 4, n is equal to 6 to n is equal to 5, and n is equal to 5 to n is equal to 3. Now how to solve this kind of problem? So which will have less energy, which will have high energy? How can you say? See, first one is n1. Okay, first one is what? n1. So next one is what? n2. Next one value is what? n2. So remember, whenever the n2 value is more, then it will have less energy. So if anyone is having N2 value is less, sorry, N2 value is more, then automatically it will have least energy. Okay, here which is having less N2 value, I told now first one is N1, second one is N2. So this is N1, less value means more energy. 5 to 4. This is what? 6 to 5. And this is what? 5 to 3. See, if you see 6 to 5. This is N1 is 6 to, N2 is what? 5. So N2 value is more compared to remaining N2 values. So if it is N2 value is more means automatically it will have less energy. You have seen in hydrogen spectrum, first one is the UV region, that is very high energy. Next one visible. So like that. So N is equal to 5 is having less IR region like that. So like that you have to solve the problems given like this.